back to my channel. In this video lecture, we will cover a new chapter of physics, that is gravitation. So let's begin with today's video. Every object in the universe attracts every other object with a force which is called the force of gravitation. Gravitation is one of the four classes of interaction found in nature. These are the gravitational force, electromagnetic force, the strong nuclear force, also called hadronic force, for the weak nuclear force. Then Newton's law of gravitation. Gravitational force is an attraction force between two masses separated by a distance r. The gravitational force acting between 2 points objects is proportional to the product of their masses and inversely proportional to the square of the distance between them. Then the value of G is the gravitational constant, where G is equal to 6.67 into 10 raised to the power minus 11. Important points about gravitational force. It is a central as well as conservative force. It is the weakest force in the nature. It is 1036 times smaller than electrostatic force and 10 to 18 times smaller than the nuclear force. Then acceleration due to gravity. The uniform acceleration produced in a freely falling object due to the gravitational pull of an earth is known as acceleration due to gravity. It is a vector quantity and its direction is towards the center of the earth. The value of G is independent of the mass of the object which is falling freely under gravity. The value of G changes slightly from place to place. The value of G is taken to be 9.8 meter per second for all practical purposes. Among the planets, the acceleration due to gravity is minimum on the Mercury. Relation between small g and acceleration is given by G equals to gm upon r square, where m is the mass of Earth, that is 6.0 into 10 raised to the power 24 kg, and r is the radius of Earth, that is 6.38 into 10 raised to the power 6 meters. Acceleration due to gravity at a height h above the surface of the earth is given by gh equals to gm upon r plus h whole square. Then factors affecting acceleration due to gravity. First, shape of the earth. Second, rotation of the earth about its own axis. Then third, effect of altitude. Fourth, effect of depth. Then gravitational field. The space and surrounding of any body in which its gravitational pull can be experienced by other bodies is called gravitational field. Intensity of gravitational field. The gravitational force acting per unit mass at Earth any time in the gravitational field is called intensity of gravitational field at that point. Then it's a vector quantity and its direction is towards the center of the gravity of the body. Then gravitational potential at any point in gravitational field is equal to the work done per unit mass in bringing a very light body from infinity to that point. Then gravitational potential energy of any object at any point in gravitational field is equal to the work done in bringing it from infinity to that point, denoted by U. Then satellite, a heavenly object which revolves around a planet, is called a satellite. Natural satellites are those heavenly objects which are not man-made and revolve around the earth. Artificial satellites are those heaven objects which are man-made and launched for some purposes to revolve around the earth. Time period of a satellite t equals to 2 pi root under root r cube upon gm, that is equals to 2 pi under root of r plus h whole cube upon g. Then artificial satellites are of two types: geostationary or parking satellites or polar satellites. Then orbital velocity. Orbital velocity of a satellite is the minimum velocity required to the satellite into a given orbit around an earth. If satellite is revolving near the earth's surface, then r is equal to r plus h equals to minus r. Then if v is greater than vo, then satellite will move on a parabolic path and satellite falls back to the earth. If v is equal to vo, then satellite revolves in circular path or the orbit around earth. Or if vo is greater than v and it is greater than ve, then satellite shall revolve around the earth in elliptical orbit. Energy of a satellite in an orbit. TE of satellites is equal to minus gmm of upon 2r. Binding energy, the energy required to remove a satellite from its orbit about the Earth to infinity, is called binding energy of the satellite. Escape velocity. Escape velocity on Earth is the minimum velocity with which a body has to be projected vertically upward from the Earth's surface so that it just crosses the Earth's gravitational field and never returns. Escape velocity does not depend upon the mass or shape or size of the body as well as the direction of the projection of the body. Escape velocity of Earth is 11.2 kilometers per second. Then some important escape velocities. Heavenly body escape velocity: Moon 2.3 km per second, Mercury 4.28, Earth 11.2, Jupiter 60, Sun 618, neutron star 2 into 10 raised to the power kilometer per second. Then weightlessness. It is a situation in which the effective weight of the body becomes zero. Weightlessness is achieved during freely falling under gravity or inside a spacecraft or satellite. Third, at the center of the Earth. Or fourth, when a body is lying in a freely falling lift. Then Kepler's law of planetary motion. First, law of orbit. Every planet revolves around the sun in elliptical orbit and sun is at its one focus. Second, law of area. The radius vector drawn from the sun to a planet sweeps out equal area in equal intervals of time. That is, the aerial velocity of the planet around the sun is constant. Then law of period. The square of the time period of the revolution of planet around the sun is directly proportional to the cube semi-major axis of the elliptical orbit. Important points. A missile is launched with a velocity less than the escape velocity. The sum of its kinetic energy and potential energy is negative. The orbital speed of Jupiter is less than the orbital speed of Earth. A bomb explodes on Moon. You cannot hear the sound of the explosion on Earth. A bottle filled with water at 30 degrees Celsius and fitted with a cork is taken to the Moon. If the cork is opened at the surface of the Moon, then water will boil. For a satellite orbiting near Earth's surface, orbital velocity will be 8 km per second, time period will be 84 minutes approximate, then angular speed omega will be 2 pi upon 84 radian per minute. That is 0.00125 radian per second. Inertial mass and gravitational mass. Inertial mass is equal to force upon acceleration, and gravitational mass is equal to weight of body upon acceleration due to gravity. They are equal to each other in magnitude. Gravitational mass of a body is affected by the presence of other bodies near it. Inertial mass of a body remains unaffected by the presence of other bodies near it. So thank you for watching my video. Hope you liked it and understood it. Thank you for watching my video, and don't forget to like, share and comment my videos, and don't forget to subscribe my channel. Thank you.